let us look at vertical shifting now. If we again look at the mother graph, the green one here, then we see what we have to do. We have to transform it by adding 1 to the y value. So in each case, if I take 0, I can add 1 and I get to the new point 1 there, which is h. If I take minus 1 plus 1 gives me 0. 0 plus 1 gives me 1. 1 plus 1 gives me 2. 0 plus 1 gives me 1. Minus 1 plus 1 gives me 0. And 0 plus 1 gives me 1. So now I've made all the dots, and now I just have to join those dots to get a new graph. If we now join the points, we get the new blue graph here, which looks exactly, it has the same form as that of the G, and it's equidistant from this graph of our mother graph. Everywhere that we measure, we will get a distance of 1. We did not change the period at all, we just shifted it 1 unit up, and we can also look at the form here. If I, for instance, go from H to I to J to K to L, I see I get a complete cycle of the graph, and then it repeats here from L to M to N, etc. So the period remains 360 degrees. The minima minus the maximum, or the amplitude, in this case our maximum is now 2, maximum is 2. Our minimum is 0 divided by 2, that gives me still a period of 1. And the roots, that completely changed, because at this stage it just touched the horizontal axis at I and M. So we just have 2 roots at I and at M, and the one is minus 90 and the other one is 270 degrees. So it means that I have to solve, to get this roots, I will have to solve algebraically that sine theta plus 1 equal to 0, which will give me a formula. We can start, for instance, at minus 90. We can say theta is equal to minus 90 degrees plus, and then we need another 360 degrees to get to the new value of the new root, where k is an element of z. And since I only have 2 roots instead of 4 for the original function, I won't have two formulas here for the theta, I just have 1. So our extremes in this case, we already know it is y equal to 0 for the minimum and y equal to plus 2 for the maximum. So in general, our formula for the minima and maxima will be like, for instance, the same. The minima will be exactly the same as the root. So the minima at theta equal to minus 90 degree plus k times 360 degrees, where k is an element of z, and the maximal will be at theta equal to, we can start at 90 degrees and then we say k times 360 degrees, where k is an element of z. And that is the vertical shifting. What we must realize here is that it makes it very simple when we plus here, then we shift 1 up. It's a plus 1 shifts 1 up. This page just gives a summary of what we said on the previous page, and the only difference is the broken line included here is the shifted horizontal axis So it's also 1 unit away from the original horizontal axis. And if you draw in that line, you can see the symmetry again as you did for the green graph. So in this case, you can just look at all the detail and see that it's exactly the same as we discussed. It is just in a neat, written down in a neat form. Here is another example of vertical shifting. In this case, we have sine theta minus a half. It means we take every y value of sine theta, which is on the green graph, and we minus a half. So we have 0 minus a half gives me h, minus 1 minus a half gives me minus 1.5, 0 minus a half gives me minus a half, 1 minus a half gives me a half. From E to N is a difference of a half, and from F to D is a difference of F to O is a difference of half, and from G to P is a difference of a half. So then we made our dots. So now we've joined all the dots to get this blue graph here, which is the graph of G. So again we notice that this graph, the minus a half, just shifted the graph of f of sine theta, shifted it down half a unit. The rest stays the same. The period is still 360 degrees. You can easily see that. The amplitude stays 1. Let us look at the roots. When we look algebraically at the roots, we will find that it's a value, k is in between 0 and 90, and m is in between 90 and 180 degrees. But let us find it. So if I solve sine theta minus a half equal to 0, it's the same as when I've solved sine theta equal to a half. So in this case, if I look at my triangle and if I value 2 there and value 1 here, 60 degrees, 30 degrees, and square root of 3 as one of our special triangles, then we see our reference angle for this is 30 degrees because it's opposite over hypotenuse. So my reference angle is 30 degrees. I have my cast rule, and my cast rule say I have positive sign there and there. So it means I have theta equal to 30 plus k times 360 degrees, or theta equal to 180 minus 30 degrees plus k times 360 degrees, where k is an element of z. So that means we have general forms theta equal to 30 plus k times 360 degrees, k element of z, or theta equal to 150 degrees plus k times 360 degrees, k element of z. So let us check it out whether our formula is correct. Then we see that when we take k equal to 0, we get 30. When we make k equal to 1, we will get 390 degrees, which is not on our graph. When we take k equal to minus 1, then we get minus 330, which is not on our graph. If I take k equal to 1, 0 in the second formula, then I get 150, which is at the point M. So this is 150 degrees. And the k is at 30 degrees. And when I look at k equal to 1, again it's off my graph because it's not in this interval here. We will find the extremes. In this case is plus a half y equal to plus a half is the maximum, and y equal to minus 1.5 is our minima. So the minima we have at I and at O, and the maxima we have that at L, and we can write down the general formulas for that. So on this page there's a summary of the vertical shifting for this specific graph, and what we must notice is that this line y equal to minus a half, which is this line here, just represent the shifted horizontal axis. So, and in this case you can see the symmetry again, and you can write down all the different values of the roots and the minimum and maximum. And here I made a note to say you can solve this equation to find those solutions, and we did that in the previous page.